Hello everyone. In this video, I will explain the change in momentum with two examples. The first one is a tennis ball with a mass m. Tennis ball is thrown downwards with a velocity vi, initial velocity. So it will strike the floor and bounces back. So this is the initial state. Here I will separate the initial and final. This is the final state. This is the floor. As I said, this ball will be thrown with a velocity vi. It strikes this floor. After that, it will be returned with a velocity vf upwards. This is the ball, and this is the final velocity upwards, vf. Of course, the same mass. And this is the final state of my problem. Here, the mass is 200 grams. The initial velocity is 6 meters per second. The final velocity is 4 meters per second. So, to talk about change in momentum, I have to define a positive direction. So my positive direction, I will select a positive direction downwards. This is my positive direction plus. So the velocity with this direction, it will be calculated as positive quantity. And if it's in opposite direction, the velocity must be negative. So I will start by initial velocity, initial momentum, pi is the initial, is equal m times vi. So it's equal to, I have the mass with grams, so I have to convert it to the kilogram, 0.2 multiplied by 6. So, and the result is 1.2 kilogram meter per second. This is a positive velocity, plus 6. Why plus 6, not minus 6? Because this VI is directed with the same positive direction that I selected, downwards. So the result is positive. The PI is 1.2 kilogram meter per second downwards. Now let's look to the final situation here, PF. The final momentum is equal mass times the final velocity, VF. The mass is the same, 0.2 kilogram. Don't forget that the mass is always with kilogram, not with gram in SI system, in international system. Multiplied so by VF. VF is 4. So the result is 0.8 kilogram meter per second. But here, the velocity is directed upwards. However, my selected direction is downwards, so I have here to add a minus. So minus 4, and the result is minus 0.8 kilogram meter per second. It's negative. Or I can write also PF 0.8 kilogram meter per second, but I have to add upwards. Now I will calculate the change of momentum. The change of momentum, here the change delta P in momentum, delta P is equal P final minus P initial. So it's equal to the P final, here is minus 0.8 minus 0.8. So I take this value, I don't take this, because here it's minus, but you can write 0.8 upwards. It means minus. So minus 0.8, this is the final. This minus exists in the expression, minus, and the initial, I take this value, 1.2. 1.2. So the result is minus 2 kilogram meter per second. Or I can write delta P is equal 2 kilogram meter per second. What does mean this minus? This minus means that the direction of delta P is opposite to my selected direction. So the direction is upwards, upwards, upwards. The change of in the momentum here is 2 kilogram meter per second oriented upwards. This is the first example. Now I will consider a second example, another example. In the second example, I have also a tennis ball here with mass M. I will consider the same mass and the same, here the same mass and the same velocity. Here the mass is the tennis ball strikes a wall. It's moving horizontally. The wall is perpendicular here. This is the wall. It has an initial velocity VI. Of course, a momentum is always with the velocity as a vector. After striking this wall, the ball, of course, will change its momentum. So it will be returned to the left. This is the ball of mass M, the same mass, but this is the final velocity, VF. I can consider this case as initial case. This is initial state. And here, the final situation, the final state. And I have to select my positive direction. For example, I can select this direction. I can to the left or leftwards. This is my positive direction. Now I will calculate the momentum, the initial and the final, and the change in momentum. I have a mass of 200 grams. Initial velocity, let's say 6 meters per second, and a final velocity 4 meters per second. Now the initial momentum, Pi, is equal M multiplied by VI is equal here with the gram, so I have to convert it to kilograms, 0.2 multiplied by 6 is equal 1.2 kilogram meter per second. Now here, the velocity VI is oriented to the right. However, my selected positive direction is to the left. So I have to add a minus here. Pay attention here. We have to add minus because I have an opposite direction. So the result is minus 1.2 kilogram meter per second. Or I can write Pi is equal to 1.2 kilogram meter per second, but I have to add right words, or to the right, or to the right. The final momentum is equal mass multiplied by final velocity. The mass is 0.2. The final velocity here the final velocity has a direction with the same of my selected positive direction. So VF here is positive. I will take VF as 4 meter per second. I will not add any sign. It's a positive. So the result is 0.8 kilogram meter per second. To the left, of course. The change in momentum is equal final momentum minus initial momentum is equal to the final momentum is 0.8. The initial momentum is minus this minus the expression and another minus here, minus 1.2 is equal to kilogram meter per second. 2 kilogram meter per second. It's a positive variation. Since it's a positive variation, so the direction of this vector delta P is with my selected direction. So I can add here leftwards, to the left. Leftwards. So my advice here to my students, take into consideration your direction, your selected direction, your positive direction. And if you change the positive direction to the right, the final result will be the same. But here, pay attention, always in the velocity, if it is necessary to add a minus or only plus, for example, here the initial state, the VI is oriented to the right and my direction is to the left. So I added a minus to the velocity, minus 6, not 6. However, in the final situation here, my final momentum, I have a final velocity oriented with my selected orientation, positive, they are the same. So the final velocity for meter per second is positive quantity, and the result is positive. Now, delta P, that's the change in momentum, is always final minus initial. The final is 0.8 minus, the initial is minus 1.2. It's a negative, and the result is 2 kilogram meter per second. Or I can say 2 kilogram meter per second leftwards. So it means that the positive is to the left. Thank you very much for your attention. Thank you.